Welcome to this announcement of the publication of the FlowSimJS Lattice Boltzmann demonstrator. This is actually the result of a student project that resulted in this JavaScript-based JavaScript and OpenGL WebGL-based Lattice Boltzmann demonstrator written by a student of our lab and extended by other students. You will find the link to this web page. It's on GitLab in the description below this video, or you can probably even read it here. So this is the start page where you come up. You see a simulation field flow coming from the left, leaving at the right. And there's already an object. Because we are in civil engineering, this object is, of course, the outline of a house with a roof. And here you see the velocity flow field. Colors indicate the velocity, so there's 40 meters per second is red and 0 meters per second is blue. Yeah, in this demonstrator we have objects that we can pick. So there is a tool line here on the left where by default we are in the picking tool line, and we can move now the roof to another place. The red line that you see here is actually a demonstration of the force acting on this line. We can demonstrate this on other objects too. Can put this object here, so this line here, and we can turn on the calculation of the force, and what you see is that this vortex here is exciting force. So we can move these objects with the picking tool. We can draw new objects like polygon shapes like this. And then we have to finish it with the right mouse button. And if you need some help on how to use it, you can press down here the help button, and this will explain what you can do. You can take predefined structures. You can switch between real units and lattice units. Lattice units is something that numerics guys use in order to understand their system. Can have different field properties. Yeah, and here is how you move your mouse. So you can also put everything aside, taking, for example, building a sphere, and then, oops, I have to pick this. If I want to close the sphere, I have to pick this and close it this way. Now what we see here is, of course, the velocity field. We can change this, for example, to the x velocity or to the y velocity. We can also look at the density, which is related to the pressure. It's called density here. In Lattice Boltzmann, this is related to the pressure. And most beautiful usually is the curl. You can also change the color scheme, but of course we start with rainbow desaturated, which is mostly the color scheme that we most enjoy. So the speed here is currently 86 million lattice node updates per second. Now, before you tell me that your code is, of course, 1 or 2 orders of magnitude faster, please take note of the fact that this runs in your web browser, and this is also, of course, still a student project that uses JavaScript and WebGL 1.0 in order to be very compatible with many systems. And this, of course, also has some restrictions in what we can do. This is why it is acceptable fast, but not extremely fast. So the resolution that you see here appears to be quite low. We can also change this by going to the parameters. Here we can change different parameters. For example, the node distance now here given in meter is 0.1. Let's make it to 0. Let's double the resolution. Let's see what's happened. Okay, so this is double the resolution. There's a small gap here in the sphere, which leads to these vortices coming in. We can also change the viscosity. Changing the viscosity, setting the viscosity lower, for example, will increase the Reynolds number. And the simulation is started again with a higher Reynolds number. Okay, and of course, what we can also do is just increasing the inflow velocity to say 30 meters per second in this case, so that we see nice development of the flow. Okay, so what will happen now is that classical Kalman vortex treats here will occur. We can again look at the forces, turning the forces on. So the position of this red line here is showing us what forces are actually acting on the sphere or on the circle, because it's only 2D, of course. And this forces will, of course, change with the direction of the flow when we have this vortex shedding here. Okay, so lengths here given in meters, we can also change between so-called world coordinates and lattice coordinates. Lattice coordinates will just tell us, okay, so this is 240 grid nodes in this direction and 600 grid nodes in this direction, and I can move this here around by pressing the middle button of my mouse and using the wheel to zoom out. Yeah, I guess that's already it. So if you want to learn more about Lattice Boltzmann, on the same channel there's an entire lecture on how this thing here actually works in theory. So the entire lecture there means it's like 20 hours, 13 lectures, 90 minutes each. Okay, have fun with this tool.